Good evening, everyone. All right. It's awesome to see so many people here already. We're going to give it another minute or two just in case people show up on time or maybe a minute late since we're actually early. And then we'll get to everybody's questions. There it is. I don't care one way or the other if you have your cameras on or off. So if you want to keep them on, that's fine. But if you want to turn them off, that's also fine. I've got the chat window up. So anybody who doesn't have a microphone can always write something in the chat window. And if you want to get my attention, you can either speak up, you can use the little raise your hand feature, right? If you got your camera on, you can wave your hand wildly or whatever until you get my attention, but whatever you prefer. But just know that you don't have to be on camera if you don't want to. Okay, it's 7:01, so let's get started. Does anybody want to start us off with a question? Otherwise, I'm going to jump right into stratified versus cluster sampling because I'm sure that's one thing that most of you are struggling with. All right, so let's start with that. Everybody can see my screen, I take it? Fantastic. Okay, so this is just, every time I have to talk about stratified sampling and cluster sampling, I go and I find this exact same website because I love their picture of it. I think it's a perfect visual representation of it. And I've never copied it and put it into my materials because I like to always go and find it every time, because literally if I go to Google and I type in, cluster versus stratified sampling, it's one of the first examples that comes up. And I do this because I like to model this behavior for you guys. A vast portion of doing your doctorate is going to be research, right? Finding stuff. So just trying to point out that Google is your friend, right? Just go out there and Google your little butts off and you'll find just about everything you need. In fact, this being one of them, right? Where students always struggle with the difference between stratified and cluster because it is very similar, right? Those two things are very similar, and it's very easy to get them confused. So on the right-hand side, we have the visual representation of the differences, and on the left-hand side, we have some English describing it. So basically, the big difference between the two is in stratified sampling, you kind of strata, right? Or divide your sample yourself, right? So you divide the population that you're looking at into these homogeneous segments. You basically think, okay, so I'm going to put all of the, so like if we were doing race, right? You could put all of each race in those 6 categories. Or if we were talking about, socioeconomic status, you could take yearly household income and break it into 6 ranges and then put people into those 6 categories. It's whatever, it could be voting affiliation where you got Democrats, Republicans, Independent, Green Party, whatever it is, but you've got those 6 quote unquote strata, right? So each one of these 6 clusters here on the left, over here on this side, you can see that they're homogeneous. These are all black dots, these are all blue dots, these are all purple dots, and so on and so forth. So everybody in this group shares a common characteristic, whatever that characteristic happens to be. Over here in cluster sampling, instead of you like forcing your sample into these clusters, right, into these strata, as they're called them, which is just a fancy word for groups. In cluster sampling, the population itself is kind of naturally clustered. They have naturally occurring groups, and the groups themselves are heterogeneous, right? Each group has all sorts of different people in them, but each of the clusters should be homogeneous amongst themselves, which means each cluster should be relatively similar to each other cluster. right? So it's the idea of a simple example would be geographical clustering, right? You could take your state and you could cut it up into 6 regions and then look at the people in those 6 regions. Now, we all know that states aren't perfectly spread out, right? If you broke them up into 6 regions, that they wouldn't necessarily be perfectly homogeneous. You might have, a lot more Republicans in one area or a lot more Democrats in the other area. But it really depends on the characteristics you care about as to whether or not they're homogeneous or not, right? You could have clusters that were totally different on one characteristic, but if that characteristic really didn't have any bearing on what you were studying, then it really wouldn't matter. You'd really be more concerned with characteristics that do have some sort of bearing. So that's really the big difference between stratified and clustered. And then how you sample from them also differs. So in stratified, you have your groups stuck in their little homogeneous groups, right? All the same people are in each of the groups, and then you randomly sample from within those groups. That's what these little dots represent, right? You take 2 from the first group and 3 from the next, and then 2 and so on and so forth. And what I like about this is it also points out that you don't have to take the same number from each strata. Normally, you would sample from within each strata in such a way that your overall sample would be more representative of the population in general. So for instance, these pictures all show equal sizes, right? There's exactly 12 in each of these strata. Well, that's probably not the case in the real world example. Let's just say the blue group makes up 10% of the population, right? Even though there's only 6 groups here. So it's larger than the others. So you would want to sample more from the blue group so that your sample that you have would be 10% blue. And then if the green group was 15% of the population, then you would want to sample enough from the green group so that it was 15% of your total sample. You kind of get what's called a representative sample. You take enough from each, you're still randomly choosing what you take from each of those strata, but the number you take is determined by the distribution in your population that you're trying to mirror, right? And that's what they mean by representative samples. If your population has 25% smokers in it, then your sample should have 25% smokers in it. If being a smoker is a characteristic, right, that matters to your study, it's that kind of thing. And so that's how you sample on the left. And then cluster sampling, once the things are, in their naturally occurring groups or clusters, then you just randomly choose a certain number of them, and that becomes your sample. So in this example, they took 2 out of the 6. You could sample 3 out of the 6, 4 out of the 6. It doesn't matter, right? Remember, you always try and sample as much as you can. It's all limited by money and time. Really, only 2 limitations. Okay, so any questions on that?
I do.
Yeah, me too.
Sorry.
Okay, so I'm looking at the homework assignment, and basically so if you look at 2.11, I'm looking at question B, and I felt that it was a cluster sample because we divided into the regions, and then we picked a certain amount from each region, which is what you just said. But then I guess you said that was wrong on my homework.
Yes, B is stratified because it divides. Oh, I can see what you're saying. It divides the United States into 9 regions with approximately 5,000 members per region, and then it randomly selects 450 members from each region. So even though the description of how they're dividing them up sounds like a cluster, and I agree with you, it sounds like a cluster, but because of the whole region things, but because they did the divisions themselves, it's kind of a gray area. But really what matters is how they sampled, because if it was a cluster sampling, they would take all of the people from a certain number of those regions, whereas instead they only took 450 people, or is it 450 members from each region. So if you look at this picture, you see how they're taking something from each region. They took 2 here, 3 there, 2 there. Well, instead of 2s and 3s, if they just took 3 from every single one of these, then that would match what B is saying exactly, that you took a certain number of things from every single subgroup, then that's stratified sampling. So try not to get caught up so much in how the groups are formed. Look more at how you're sampling from each of the groups. If you're taking all of a few of the groups, then that's cluster sampling. If you're taking some from all of the groups, that's stratified sampling. Does that clarify it for you?
Okay. It's still confusing to me, and I think it's because in previous courses, I've looked at it as I don't know, I just looked at it the way that I just explained it before. So with cluster, I don't know, I'm confused.
It always comes down to how you take your sample. Try to ignore how the things are divided up. Once they're divided up, it doesn't matter, because both stratified and cluster, they both get divided up. So that becomes a moot point. So the fact that they were divided into regions or whatever, who cares? All we know is that they're divided into groups. And once they're divided into groups, that tells us, okay, we're either going to do a stratified sampling or we're going to do a cluster sampling, because those are really the only 2 sampling techniques we use when we have our population stuck in groups, right? And strata is just a fancy way of saying groups, and clusters is really just an informal way of saying groups, right? They both mean the same thing, that your data, your objects, whatever you're studying are put into little subcategories. Once they're in subcategories, once they're in their little groups, if you take a little bit from all of the groups, that's stratified sampling. However, if you take all of the objects from just a few of the groups, that's cluster sampling. And I really think you need to concentrate on this picture, because that really illustrates it really well. That if you're taking a little bit from every group, it's stratified. If you're taking all of it from some of the groups, it's cluster. And from this description, it should be fairly obvious that it's stratified, because they took 450 from each region. So they're taking some from every group, and that is stratified.
Okay, I think that made more sense to me.
Yeah.
I think I got it. Stratified some from every group, and then cluster all from some of the groups that were chosen.
Exactly. And so, for instance, with this example, because they have roughly 5,000 members per region, if they then said, then they, went and took all 5,000 members from region 1 and all 5,000 members from region 2, then that would be a cluster sampling.
Okay.
All right. Any other questions related to cluster and stratified?
I have 2 questions. Not based on this one. One is the assignments. We do it every week, So the system, Canvas system, we use it when we're going to submit our assignment. There's only 2 ways that I have learned, One way is when you prepare your documents, when you want to submit, and you click the unit for the assignment, and it becomes open, all is open, and it says start your assignment. Then you click start your assignment. When you open that one, start, then you open the file. Open the file, done.
Yes, that's correct. I emailed you back with those same instructions.
Then I open the file where I save it, whether it's a document. Then I open that one, then I submit it. That's one way. The discussion.
No, stop right there. Stop.
Okay, okay.
That is the only way. There is no other way to submit your work. So
Okay.
whatever you've done in previous courses, please stop doing it here. You do not submit anything to the discussion boards. The
Okay.
discussion boards are for nothing other than discussing topics. You will not upload or submit anything to the discussion board. So what you just described is the one and only way of submitting things.
Okay. Because when you look the assignment, it has two parts. The first part is the paper you write it, and that's the way you submit it. The other thing is to submit, there's another one, action, action items, some exercise you work. That exercise we are working can be, I use two ways, when I do Excel or I do a document, Word document with tables, So do I have to keep or do I have to send that exercise? When I send it the same way, deleting the first paper I submitted, and taking the second one. So in the discussion box over there, when I open the discussion, it becomes reply. Like if I want to reply, I have to copy and paste over on that cell, the assignment. The problem is, if I prepared an Excel or table, you cannot see it because it's mixing when I copy and because it's not coming up. It's coming all words, mix it up. So how can I submit the second part of my assignment, which is the action required, the numbers that I'm doing with Excel or Word document?
Okay, so I don't know where you're seeing this. I'm looking at the page right now, and nowhere does it have a second action item that says you're supposed to submit things to the discussion. So where are you seeing this?
Okay, when you click, the assignment unit, it will say start the assignment.
Yeah, I'm here.
Okay, when you that
Here's
one,
homework one, start assignment.
If you read the first
Yep.
down, I told you it says you have to discuss, the paper. You are writing a paper. The application of the first 20th century. You have to write your own words. There is it's only ABC, something you have discussed, on write your own words, describing. That's the paper I submitted. The other papers under that, it says working together with other students, or there's some numbers listed over there.
Okay, so I'm sorry, but hold on,
Yeah.
stop, please.
Okay.
I'm sorry, you're misunderstanding the instructions. When it says discuss, it just means that when you list an answer, you can't just say the answer is yes. So let me give you a perfect example. For question 2.9, right here, it says, were the techniques used in sampling the sample likely to produce a sample that was representative of the population of interest? And the answer is no. Well, you can't just answer no. You have to say no, and then why, right? So that's what it means by discussing your answers is you can't just say yes, no, this, that. Sometimes you can if it's a real simple thing. So for instance, what's the population of interest? Well, the answer to that is just simply blank. You don't have to justify what it is, right? What is the sampling frame? Again, you can just say it's blah. You don't have to justify, your answer because that's an obvious thing. But when it asks for things like yeses and nos, those you're supposed to justify. And that's what it means when it talks about justifying things.
When I justify, I wrote this, when you open the assignment, you are going to answer all those questions, put down to answer all the questions. After I finish, where I do.
Okay, so once you've answered all of these questions, you've written everything up into a Word document.
Okay, where I put it.
You click right here where it says upload file.
Okay.
Then it says choose file. You click there and it'll open a little, what's called a Word Explorer or a Windows Explorer. You go to wherever your stuff is, right? So I go to my Franklin, I go to my 807, I find the file that I want to upload. Let's say it's this one, and that puts it there. And then when I'm ready, I just click submit assignment and it'll upload that file to See, says submitted. Yay.
Okay, I
And so now it's
submitted.
there.
Dr.
there was
McBride,
another
what he's
paper
talking
before
about
that.
is the objectives. Do you see under the purpose where it
Yeah.
says discuss the importance up at the top? If you keep scrolling back up, not the
Yeah,
action.
this one, this
He's looking at the
assignment,
objectives for the
these two
assignment,
assignments.
where it says
Objective.
discuss the importance in application of statistics in the 20. He was answering those
Oh.
questions.
Okay.
That's I did paper. That's the paper I did about 3, 4, 5 pages. Then
Yeah.
I submitted it.
Well,
Then when I answered the other one, I have to do again, submit the same way, but it deleting the first one in the system, you know.
well, all I know is when I looked, it still has your old paper with all of this stuff written, but this is not what you're supposed to answer. Purpose is like your learning objectives. This is just what we expect you to learn from this week's work. You're not supposed to answer these questions. All you're
I am
supposed,
not supposed to write that question, you know, because I
No.
know that paper. I discussed it, the importance and application of statistics in the 21st century.
yeah, I know. I know.
I submitted that one.
I know, and
Unless
that's
unless
that's great
I
that you did the
answer the
time, but
other
it's a
one.
wasted. I don't want to see that. I don't need to see that. That's not your assignment. You didn't need to submit that. You're only
Hey, look
supposed
here,
to
submitting, or I don't
do
know.
the
that's what
homework.
we use it. Okay. I don't know.
just do the homework questions.
Only the homework questions. Okay, I will do it. So I will
Okay.
delete that one. I don't worry about that paper.
Okay.
That's
Okay.
the conclusion I have. Okay, the other question I have. There's another question I have over there. Where did you save the last meet sections recording?
Go to announcements.
The last meet session. With
Yes, I
one-
know. I'm
Where
showing
did
you.
save it?
Can you
I-
see my
I have
screen?
photos.
Just look at my screen. Go to announcements. Right under here, Google Drive access, click on that. This is the link that takes you to our Google Drive. You're going to want to bookmark this in your web browser because you're going to go here all the time. When you go to our Google Drive, it'll bring you to this page, right? This is our Google folder. And this file right here is our meet sessions. If you double click on that, it'll open it up. And these are the hyperlinks to all of the videos that I've done for all of the meet sessions. This one, the one on the bottom, is always the newest one, right? They go chronologically downward. So this one right here, if you click on that, it will open the video from Monday.
Dr. McBride,
Yes.
I think where he got confused is where I got confused with that, because I was looking for the date. So that's why I emailed you, because I was looking for the date of it. And I forgot that you had said it's always going to be the last. I'm sorry, my kids. It's always going to be the last one there. And when I looked, I'm like, March, that's not right. And that's why I was like, I don't see it. I don't see it when I was emailing you, but I think that's what threw me off. So
Right.
I think, yeah.
Yes, I apologize. I put March instead of August. So I've changed it. There it is. All right, what else?
Okay. I have a question because at the on question, I'm looking at the assignment. I don't know. I read the book. I looked at majority of those videos, and a lot of this stuff that I don't know if it was stuff that we were supposed to already have learned from somewhere. Like, I've learned about this stuff, but it's like I'm getting different interpretations of it. I don't know what's going on, but this was really kind of hard for me. I was struggling. So on 31, because I'm still on the stratified and whatever, on 31, when I put stratified, which goes with exactly what you just told me, because we took some from a list.
Do you mean 13?
31.
31
231.
31 doesn't ask about
231?
doesn't ask about
2.31?
doesn't
It
ask
says,
about
what is the sampling frame?
Yeah, a sampling frame isn't a sampling technique. A sampling frame is what is your sample, right? So if you're trying to decide how fifth grade students react to the pandemic and you go to your local elementary school and sample 35 kids from the fifth grade of your local elementary school, then that's your sampling frame. It's those 35 kids from your local school. The sampling frame is what your sample is. It's just basically describing your sample.
So would the sample be the information that we actually use,
No.
or would it be?
The sample is the objects that you gather to take data from. So for instance, in this question here, right, a transportation researcher is funded to estimate the proportion of automobile tires with an unsafe tread thickness in a small northern state. They randomly select 1 month during each of the 4 seasons for taking the measurements. During each of those 4 selected months, the researcher randomly selects 500 cars from the list of registered cars in the state and then measures their tread thickness for 4 tires. So basically 4 times a year, right? So 4 different months throughout the year, they randomly selected 500 cars for a total of 2,000 cars. So their sampling frame are basically those 2,000 cars that they randomly selected over those 4 different months. That's their sampling frame. Just the cars, the 2,000 cars. The population of interest is basically all cars in the state, right? Because that's what they're interested in, right? They're interested in knowing what proportion of automobile tires with unsafe tread thickness are in their state, right? So their population of interest is just all of the cars in their state. The sampling frame are the 2,000 cars that they randomly chose, and then the biases come from that. So that's what a sampling frame is. It's not the tread thickness that you measured from the cars. It's not the tires. It's just the cars. It's the things that you took.
So it will be, instead of it being 500 cars, it will be 2,000 cars because you're actually doing 2,000 cars.
Yes, because you randomly took 500 cars each month 4 times.
Okay. And as far as, I'm sorry for it. But as far as the biases, are these biases that come from what we perceive from reading this? Like there's actually a right or wrong answer for the biases?
The biases are based on the scenario. So based on how they sampled the cars and the population that they're trying to model, right? They want to know something about all of the cars in the state, but then they sampled 2,000 cars this specific way. Well, based on that specific sampling technique, what are some problems? What are some biases that could result in your, that could come up in your data?
So I put measurement bias as one of them because I felt that, the way that we're measuring this could possibly be a bias.
Well, a measurement bias, you're thinking of something else for a measurement bias. They're obviously going to have a tool that measures tread thickness. That tool is not going to be biased. It's like using a ruler. A ruler is going to measure a 1/2 inch every time you use it. So whatever the tool is that measures the thickness of the tires, it's going to accurately measure the thickness of all the tires. And even if the tool itself is faulty and it's not measuring the thickness properly, it's not going to be biased because it's going to be wrong the same amount on all the tires. So that's not a bias. What a bias is basically something that makes your sample differ from the population you're trying to estimate something about. Now, they want to know what's going on with all of the cars in their state. What's wrong with sampling the way they sampled? Somebody give me one bias for this sampling technique.
Not all cars are registered.
There you go. Number 1, not all cars are registered.
Not all cars are used during the winter months.
There you go, Susan. An awesome other example is not all cars are used during the winter months. So because they selected, sorry, somebody else have something else?
I was saying some of the cars were from out of state and wouldn't be on the state list.
There you go. Fantastic. Exactly. So the two big problems we're seeing is that they're only pulling from cars that are registered in the state, and they're only pulling cars at 4 specific points in time. So those are the two things you have to think about as far as, can either of those two specifics create a bias? And yes, they can, because if I want to know something about all the cars and I'm only looking at registered cars, well, there's plenty of cars on the road that either aren't registered at all, or, as Lloyd properly said, are not registered in that state, right? Somebody could have just moved to the state and they haven't changed their title over yet. Somebody could just be on vacation or on a long-term vacation. I mean, there's lots, they could be in the military, right? There's all sorts of people that are, TDYing from one military base to another, and they'll be there for 6 months or a year, and they'll never change their registration because they know they're leaving soon, right? So there's all sorts of reasons for that. And then the fact that they only looked at cars from 4 specific months. Let's just say they went, December, April, May, June, July, August. I think that's 4. I don't know. Basically go 4, 8, 12, and I guess what, 1, 4, 8, and 12. There's your 4. Well, like people said, there are a lot of cars that wouldn't be on the road in December, especially in a northern state, or wouldn't be on the road in January in a northern state. There could be people that are called snowbirds who, during the winter months, they leave and they go south where it's warm, right? So their cars won't be on the road, for 4 or 5 months out of the year when they're gone. So both of those sampling techniques of only getting registered cars and only getting them at certain times of the year is going to introduce bias into your sample. It's not going to be perfectly representative of all cars on the road in that state throughout the year. Okay, that's what biases are. Okay. Somebody had asked, would I mind going over completely randomized design, randomized complete block design, or Latin square design? Ugh, those are horrible, guys. Really, honestly, it's never going to come up again. So I wouldn't waste a lot of brain power on it. I would just Google those 3 things and read about them. It's really the block design, the completely randomized design and the randomized complete block design. The real only big difference between those two is that the block design is blocked by something. So for instance, the glazing question that we have in our homework, where the guy is making, the guy or girl, whatever it is making pots, and they've got a kiln and glazes, and I can't remember what number it is. Where is it?
It's 22.
22, right there, right? So the person looks at their stuff from day to day, right? See, so it says, since conditions in the kiln vary somewhat from day to day, the experiment was conducted over an 8-day period. So every day they gathered a new set of data. So that is like the clue that tells you that this is a blocked design. So, it's a complete randomized, complete randomized, however the way you want to say it, block design, and it's blocked by days because it's looking at each day as kind of a new set of data. It's almost like, cluster sampling or something where it's clustered by days, but because it's not one full set of data that is separated into things, and it's a whole new set that happens each day, it's not a cluster sampling. I'm just trying to show you kind of the similarity of how things are clustered versus blocked, right? So you're just blocking, you're looking at things day to day. And it's a 2-factor structure because you're looking at 2 things. You're looking at the type of glaze that was used and the thickness of the glaze. And then you're assessing, how things are different. So it'd kind of be like, if you remember back to Monday, we had the example where they had a bunch of different fields and they put different fertilizers in all the different fields. Well, it kind of be a similar thing. Instead of, if you looked at different fields, if you looked at your yield in one field every season, right? So every year you grow the same crop. And at the end of the year, you measure your crop yield. Well, if each year you tried a different fertilizer and or a different amount of the fertilizer, then you would be blocking year to year. And it'd be a 2-factor study where you'd be looking at the type of fertilizer and the amount of fertilizer. Now, obviously, that would be a very long ass study because you would have to do a different thing each year, right? So year. But you get the idea that that's what the blocking is, and that's what the factors are. It's basically the differences that happen from experiment to experiment, right? And each experiment is conducted over a day. So day 1, I'm going to try glaze A, and I'm going to put it on thin. Day 2, I'm going to try glaze A, and I'm going to put it on thick. Day 3, I'm going to try glaze B, and I'm going to put it on thin. Day 4, I'm going to try glaze B, and I'm going to put it on thick, right? So that's the randomized block design, blocked by day, with the 2 factors being type of glaze and thickness of glaze. And then Latin squares, it just makes my head hurt. I don't even remember off the top of my head what it is. I'd have to look it up, guys. And if I have to look it up, then it's not important enough to know. Lloyd?
One thing with that Latin square, that's what I answered for. In the book, it said that the Latin square had like 2 factors. They said like it was a block design that has two
factors.
Yeah.
It could be, but there's probably something else to it that makes this a randomized complete block design and not a Latin square.
All right. Thank you.
I mean, I would literally just go Latin square design.
So we're using,
versus.
Okay, the question is, we are using ANOVA when we're doing that, block, randomized blocks. So we have to use ANOVA system,
Well, you would only use ANOVA if
Yeah.
you were gathering ratio level data. And I think if you're looking at type of glaze and thickness of glaze, that ain't ratio level data. You'd be doing a chi-square analysis, if anything.
All right, okay, thank you. That's great.
Dr. McBride?
Yeah.
Can this term blocking, I think it's, I'm not 100% getting it. If I kind of put it back to my, because my master's work, I was one of those bench scientists that wore the white lab coat, but I kept track of really good records, like for batch numbers and stuff like that. Is that, if I'm thinking about blocking, what I think of it as like, it's part of your record keeping, that you're trying to keep track of, like with the question number 21, it was blocked by hospital because
right.
You were testing the drugs at each one of the 10 different hospitals. You were testing 2 wards with each drug at each of those 10 different hospitals. And what I was trying to think about is if I'm blocking it as kind of a record keeping thing, that way if I saw some wonky results and it only happened at one of the hospitals, it's kind of blocked, that variance that is blocked. So that I'm kind of keeping record that it's maybe something more to do with the hospital than it is to do with the drug. If I saw that wonkiness across all of them, then I'd have to say there's something going on with the drug.
Yeah, absolutely. That's
blocking, like record keeping is.
It's record keeping. I would say instead of blocking being like record keeping, I'd say record keeping is a component of blocking, because blocking is really just a way of repetition. It's a way of repeating your experiment over and over again. So in the case of the kiln thing, right there, he or she is firing something in his kiln over and over and over again, and each day is a new experiment. As far as the 216, the hospital drug experiment, they're basically applying the same set of drugs, right? D1, D2, and the placebo. They're doing it at this hospital. Then they're basically redoing that experiment all over again at this other hospital. And then they're redoing the experiment all over again at this other hospital, right? So it's a repetition. So a block is a way of repeating your experiment. That's really what a block is. It allows you to repeat your experiment. And then of course, yes, very good record keeping would have to be a part of that blocking. So like you said, if you saw something wonky happening in one hospital, but not in the rest, then you could probably just throw that data out and think that, something was going on in that hospital. So yeah, record keeping is a part of blocking, but it's not what blocking is. Blocking at its core is a way of replication. It's a way to basically do your experiment over and over and over again.
So for the one that you was just talking about, so would the answer for block be the D1, the D2, and the placebo?
No, the blocks themselves are the ways in which you replicate the experiment. So with the kiln, the blocks were the days because you redid the experiment day by day. In question 16, the blocks are the hospitals themselves because each hospital is where you redo your experiment.
Wow. So I don't yeah, this is a
I told you guys this first week is the worst because it's all vocabulary, right? So it's here's the dirty secret. Week 1, nobody cares. It's vocabulary, right? It really is just vocabulary. If a lot of this is making your head hurt and you don't get it, who cares? It's just vocabulary. It doesn't matter. What's important is, do you understand the basics of statistics? Do you understand what a sample is? Do you understand basic sampling techniques? Do you understand what a good sampling technique is versus a bad sampling technique? Do you understand the different levels of data? That's more important than anything else. And they don't even talk about this in this homework section, but do you understand what it means to be ratio level data? Do you understand what it means to be nominal level or ordinal level data? Because that's really important, because that tells you whether or not you're running an ANOVA versus a chi-square, right? So those are the important things. Whether or not you understand that a hospital is a block and factor levels are D1, D2, and a placebo, who cares, right? Granted, you want to get the right answer so you can get your score on your homework, right? But in the grander scheme of things, none of this matters. You can always look it up, really. And unless you're going to run an experiment that has these specific types of things, you're never going to discuss this again. You need to be able to describe your experiment well and your thesis well. And if your thesis is being replicated, then yeah, you better understand what a block is, because you're going to have to talk about how you blocked your experiment and you ran it over and over again in these different blocks. But if you're not doing that, then who cares? Okay, so I'm not saying that to minimize your question. I'm just saying it to hopefully minimize your stress levels. So
no, but Jessica would like for you to go over the covariates.
Covariates?
Yes.
Yeah. Okay. So covariates are an interesting thing, because if you look at the book says there are no covariates at all. And I tend to disagree with that. A covariate is basically, it's almost like a confounding variable. It's a measurement that might or might not influence the results of your experiment. And it's usually something that you either control for or try to control for. So in the example of the hospitals and the drugs, some typical covariates would be the age of your patients, because that can have a bearing on, isn't this something to do with high blood pressure, if I remember correctly? What's the scenario for 16?
Yeah, BMI and high blood pressure.
Yeah, exactly. So obviously, let's see, all 6 patients in each of the wards will be given the same treatment: age, BMI, blood pressure, and a measure of degree of illness are recorded, right, for each patient upon entry in the hospital. Okay. Let's see, they're treating a particular illness, placebo to the researcher. Yeah, so they don't tell you specifically what the illness is. They don't specifically tell you, obviously, what the drug is. They tell you that they're going to measure on, right? So on all their patients, they're going to take their age, their BMI, their blood pressure, and then how sick they are. And then they're going to give them one of the 3 drugs, either D1, D2, or the placebo. And then they're obviously going to see how well they progress, right? How good the disease gets, like how good it is at curing this disease. So you could almost think of it as like COVID right now, pretty pretty common, easy thing to wrap our heads around, where COVID would be the disease. You would have Moderna, Pfizer, and the placebo, right? As the three different things you could give your patients. And then at the end of it, you're basically measuring how sick they are after a certain amount of time. Now, it doesn't really quite match because obviously Moderna and Pfizer are vaccines and you give them before they're sick. But if we just considered them as being two different treatments for somebody who already has COVID, then that would be kind of a similar concept. Now, we all know that as far as COVID is concerned, there are quite a few what they call comorbidities, things that make you far more likely to die from it, or at least have severe symptoms from COVID. And those comorbidities are your age, weight, right? If you're obese, which is obviously a measurement of BMI. Basically, if you were a smoker, right? Your fitness level. There's all sorts of things like that they're showing are comorbidities for COVID. So those would be things that you would measure from your patients, because those would be considered covariates. Kind of the same thing as confounding variables. They're things that can influence whether or not your patient recovers from COVID, whether or not the medication you gave them was effective, right? So in this study, whether or not D1 is effective, D2 is effective, or they just get a placebo effect, all of those things could be affected by their age, their BMI, their blood pressure, and how sick they were when they first showed up. So all of those things, in my opinion, which differs from the book, would be considered covariates. The book says there are no covariates. There are answer guides floating around out there, and the answer guide for the book for that question says none. And in fact, for the experimental units, instead of patients, it says wards. So, that's the other thing that I want to caution you guys about this chapter is, because we're dealing with vocabulary, there can be some discrepancies between answers. And you can make an argument that the experimental units are the wards, absolutely. But the experimental unit can also be argued, in my opinion, far more strongly that it's the patients, because the experimental unit is usually the thing that you are taking measurements on, right? And the measurement unit would be the degree of sickness, because that's, like if you're measuring someone's height, then the measurement unit would be inches or centimeters, depending on if you're in the United States or anywhere else in the world that uses the metric system. Well, in the context of this question, they're measuring the degree of illness of their patients along with age, BMI, blood pressure, right? So obviously the measurement units are those things, right? So in age, the measurement units would be years. BMI, the measurement units would be, I don't know, digits. I mean, a BMI doesn't really have a unit of measure. It's just, you're a 24.2, you're a 26.7, whatever it is, right? Blood pressure, I don't know what they're in like kPAs or something, kilopascals or something is a measurement of pressure. And then a degree of illness, well, that's a measurement unit, right? How sick are you? And they give you the little thing and you choose the smiley face down to the sad face as your degree of illness. That's kind of the measurement unit that they're using. So because they're doing all those measurements on the patient, I would argue that the measurement unit, that the experimental unit is the patient, because that's the thing that's being measured. I don't know how the book could argue that it's the wards, in all honesty, but some people would say, well, if the hospital is the block, and then I'm looking at individual wards within the hospital, then those become my experimental units. But then my response would be, yeah, but are you measuring the wards? You're not measuring the wards. You're measuring the people. So the people are the experimental units, right? So it's one of those things.
So would the replication be the 2 wards?
Yes, the replications exactly would be the 2 wards per drug in each of the 10 hospitals. So you end up having, 2 wards per drug. So that's 6 wards times 10 hospitals. You end up getting 60 replications. Lloyd.
Yes, my question is, in that example, wouldn't each ward be 1 and it's 10 replications of each ward? I mean, it's like 10 experiments of the same thing. Isn't that a replication? So isn't it 10 replications of the 6 patients taking the 2 separate, I mean, the 2 different and the placebo?
Well, the replications in general are just the 2 wards per drug in each of the 10 hospitals.
So it would not be that it's 10 replications of the test of the 6 people. So it wouldn't be 10 replications of the same 6 people, basically.
Well, are they doing that? They said they selected
Yeah,
10
it says in
hospitals.
10 wards, they're having 6 people in each ward, and 2 takes, each medicine, 2
Well, it
takes
says
the
all
placebo.
all six patients in each of the wards will be given the same treatment. So within each hospital, 2 wards are randomly assigned to administer D1, 2 wards to administer D2, and 2 wards to administer the placebo. And then all 6 patients in each of the wards get the same treatment. So each ward is its
ward.
own like little cluster, right? That one ward, all 6 patients get the same drug. It's almost like, it's its own block,
Oh,
right? That ward
I see.
gets this glaze, and then this ward gets a different glaze, and then this, so it's that, so that you can see how the wards are the replications. Because
Right, I read it
all 6 of
wrong.
those students are also, sorry, all 6 of those patients are all clumped together in one ward, and they're all getting the same treatment.
Right, I read it wrong. I thought that they were I read it wrong. I was
Yep.
reading like they were receiving 2
Different
2 and
things.
2
Yep.
in each
Yep.
ward. Okay,
No worries.
thank you.
Yep. All right. So somebody says, I'm not sure age, BMI, blood pressure, and a measure of screen will be covariates or just information captured. Yeah, Jessica, I'm with you. I mean, from the description of this question, I think it could very well be interpreted that that's just information captured. Or you could argue that they're covariates because you're probably only concerned with the effect of the drug. Right?
Thank you. I wasn't quite sure on that one when I looked at it, because like the one about tire tread, that's my background, but I know nothing about medical. So I'm like, I kind of guessed, and you could not Google and find out covariance for medical testing without getting a whole lot of stuff.
Yes, a lot of stuff. Yeah. And I personally would think that they're covariates mainly because as a researcher, you don't have control over any of those things. You only have control over the drug that they're given, right? So those become your treatments. Those become the things that you're measuring to see if they have an effect. And everything else that could possibly have an effect on your outcome that you're measuring, i.e. how much they recover, would be considered covariates. So those are considered covariates because you have no control over them.
One question. So where it says in here, each hospital concludes, there may be aspects of the hospitals that may result in the elevation of responses at some hospitals. So would that be a covariant, the aspects of the hospital that may elevate the responses?
Well, elevation of responses at some of the hospitals. I would think that would be more of a confounding variable than a covariate, because that's more of almost like the way that's worded to me, that sounds almost like a voluntary response bias, right? Where you have, it may result in the elevation of responses at some of the hospitals. So yeah, I mean, you could probably argue either way. I think that's kind of a throwaway sentence.
I use that as justification. That's why I chose the hospitals as the block.
Sure.
Because you're trying to block that variation.
That aspect out. Yeah, that makes sense. Yeah, that's a good point, Amy. That would be a good justification for that, right? Because each hospital might be different in this aspect. So by blocking it out, you can hopefully see those differences that way. Wouldn't you discriminate or limit them if they were known to have an effect? Eduardo, are you talking about the age, BMI, and blood pressure stuff?
Correct.
Yeah. Well, how can you discriminate or limit age, BMI, and blood pressure?
Well, if I know that I'm looking for the effect of the medication, and I know that it's not effective on, for example, children or people of certain age, I would just not use them.
That's true. That's good. But you would still have an age range of the people who are getting the drug. And there might be an argument that even within that range, there's an effect, right?
Okay.
The problem is yes, in an ideal world, if we really want to know if a drug works or not, we would want to be able to strictly say who gets it and who doesn't get it, so that we could really get rid of all confounding variables. But that's in an ideal world. Obviously, in the real world, we can't do that. A hospital can't say, sorry, bub, we're not giving you it because you have a BMI that's too high, or you have a blood pressure that's too low, right? You just don't get any treatment today. So yeah, so it would be great if we could get rid of those things so we could see whether or not, and that's what clinical trials are all about, right? Because in clinical trials, they can control for those things because people volunteer for them and they say, okay, all of you high blood pressure people are going to go over in this group, and all you low blood over in this group, you know, so then you can control for those things. Yeah, great question. And I'm glad you brought that up because, and I think it really only comes up in this chapter mostly, is you have to read these questions and answer these questions in a vacuum. Don't apply them to the real world, because when they ask you things like, you know, how would you eliminate the confounding variable? Well, in a real world context, you can't. But in a vacuum, you know, as a thought experiment, what would you do to this situation to get rid of that confounding variable? That's what they're asking for questions. Like for 2.2, I know you're trying to get rid of a confounding variable that's impossible in the real world. And I thought there was another one that I could remember off the top of my head that was similar. Maybe it was just 2.2. Yeah, it's just 2.2 because there's two different ones in there. It would be impossible to get rid of the confounding variables in 2.2 in a real world aspect. Well, I take that back. You could get rid of it with the software program, but you really couldn't get rid of it in the medical.
And that's the one thing that tripped me up from the very first, this is Susan,
Yes.
was that I looked at it and I said, there isn't any way that I could, if I were to replicate it or do it over again, I'd have to still do the intervention. I'd still have to do the screening protocol. So there wasn't any way to pull out the confounding variable that I saw.
Right. Yes. And
For ethics reasons and nothing else.
Yes, exactly. And that's my point. For ethical reasons, you can't get rid of the confounding variable. So in order to truly answer that question, you'd have to put it in a vacuum and say, okay, ethics aside, if I was going to design an experiment to truly test the effectiveness of this new medication, this is what I would design. And then that's how you would go about basically answering that one. And think about it, guys, from the standpoint of what is this question trying to get you to learn? It's not trying to get you to learn how to be an ethical hospital administrator. It's trying to get you to learn what confounding variables are and how you could control for them in a laboratory environment. So that's what it's trying to get at with these scenarios, is if you could turn it into a purely thought experiment, how could you get rid of those confounding variables? Because that then gets you thinking about, what is the confounding variable really doing? What kind of effect does it have? Okay, so then how do I minimize that effect? Because if you can think about how to minimize an effect, that means you're really thinking about what that effect is. And that's the ultimate goal of these questions is, you've got an intervention that is specifically, hopefully, supposed to change some response variable, right? Supposed to improve a situation. And then you've got these other confounding things that muddy the waters. And you need to be cognizant of that whenever you're running an experiment or gathering data. By seeing these examples, it gets you thinking about it so that when you go and run your own experiment, you start thinking to yourself, okay, now wait a minute, what things could be screwing with my results? What things could be muddying my waters? And then you go through and you list all possible confounding variables you could come up with. And then you ask yourself, okay, how can I control for these? Can I eliminate any of them? And if I can't eliminate them, then can I control for them? And if I can't eliminate them and I can't control for them, then how do I discuss them so that my results, people who look at my results know that they still have these confounding variables in them, so that I'm not basically being dishonest. So that's all we're trying to do.
So for that one, could the confounding variable be like symptoms of the stroke?
Are we talking about 2.2 or 2.16?
2.2.
So 2.2, really the problem with 2.2 is the confounding variable is the year in which the patients were admitted to the hospital, because they had two completely different kind of admittance procedures from last year to this year. And so they've completely muddied the waters. I mean, there is literally no way of telling if this new medication has any effect whatsoever, because they've got a completely new protocol. So the only way to eliminate that confounding variable of, you know, it being different from this year to that year would be to be unethical and run an experiment. And when people show up with, you know, a heart attack or whatever it is that they're having problems with, you go, okay, you people are going to get this new medication and you people are going to get a placebo, and we're just going to cross our fingers and hope you don't die. Right. and that's really it. I mean, that's the only way to do it, is to give one random, randomly assign your stroke patients to either get the new clot medicine or to get the placebo. Now, in an ethical way, the only way you could do that ethically would be if the new blood clot medication was a new medication, then you could randomly assign people to the new medication and the old medication and see if the new medication has a higher success rate. That's still ethical because the old medication worked, right? But if there's been any kind of research done on this new medication at all that shows that its effectiveness is substantially better than the old one, then you're now back into unethical territory, and you can't randomly assign them to the two, because you know that this second one is supposed to be a lot better, and you're going to get your ass sued off by anybody who got the old one, right? So that's why we have to answer these things in a vacuum. The second one's a lot easier, right? Because the explanatory variable is the software program, and the confounding variable is whether or not the students choose to stay after school for this hour to use it, right? That's a big problem, because the type of student who's going to choose to take an hour out of their day to use this program is already going to be a better student, you know, so you're going to be inflating their scores just because of that. So the only way to get rid of that confounding variable would be to take all of your students and randomly assign some of them to stay after school and some of them to not stay after school. And again, that's not very ethical, because you're not allowing students to stay after school who might want to, and you're forcing students to stay after school who might not want to. Lloyd.
Yes. In that example, what I thought that like it was confounding because some students are studying, some are not. But if you're trying to determine the effectiveness of this particular software program, wouldn't it make sense, since to have the students all come in for that hour study, half of them use the software and half of them study from different methods? And,
absolutely. Absolutely. And here's the difference between the two scenarios, Lloyd. Your scenario, where some of them randomly use the software and some of them randomly use some other study technique. Now what your study is going to do is show whether or not the software has a different effect than the other study technique. If you had some of them use the software and some of them do nothing, then that study would show whether the software has an effect over doing nothing. And you see how those are two completely different questions that you're researching. So it all depends on what you're researching. But yes, you're absolutely right. Both of those scenarios would test the effectiveness of the software versus something else. It just depends on what you want that versus to be. Okay. Any other last minute questions? We're already a few minutes over.
Yeah, I have one last question. It's just quick. So on 2.23A, on question B, are they asking two different questions, or are they telling us to pick?
So in question A, you're supposed to pick which of the two designs you think is better. In question part B, you're supposed to answer whether or not you think this scenario they give you would be a problem with either design A or B. It's kind of sucks that they have this, you know, design A or B and they have questions A or B, but you have these two different designs. And then for this second question, regardless of, you know, which design you chose in the first part, you want to answer this question based on both of the two different designs. So would it be a problem if you use design B, and would it be a problem if you just use design A, and why or why not?
So basically I need an answer for both of those.
Yeah, you basically need to say, okay, would taking one recipe out be a problem for the design B, and would it be a problem for design A? Why or why not? Right? So they could both be yes, they could both be no. Maybe it's a problem for A, but not a problem for B. Maybe it's a problem B, but not for A, right? And you have to kind of justify why you think it is one or the other.
Okay, so I put that it would have been a problem for design A because they only had one, was able to only taste one, but I got that wrong.
Right, because so design A, you take your 100 customers and you randomly put 20 people on each of the 5 recipes so that each customer tastes only one recipe, right? Well, if you decided that one of the recipes was just terrible, there was no point in having anybody try it, then you would only have 4 recipes, and you would take those 100 customers and you would just put 25 people on each of the 4 recipes, and the overall design of design A would be the same. So it would not be a problem to eliminate one recipe. Design A would still be the same. Now, design B, you take 100 customers, right? And they taste all 5 recipes and then, you know, like rank them. But if you take one of the recipes away, then now they're tasting 4 recipes each and ranking them. So again, it really doesn't have any influence on the effectiveness of design B either. So
as long as you're changing it equally, right? As long as you're making a change and it's equal.
Well, yeah, I mean, because you're taking one recipe away,
Yep.
doesn't change the overall aspect of the design.
Right.
Yeah. Now, between those two designs, one is definitely better than the other for, you know, doing what you want to do.
Yeah.
All right. Anything else before we go?
I have a question.
Yes.
So this was really helpful, just sitting back and listening to people's questions. So thank you everyone for asking questions. My question has nothing to do with what you went over, even though it was extremely helpful. Going to SAS.
Yeah.
I just want to make sure that I was thinking about that aspect correctly. So what I did, I think this is what I was supposed to do. I uploaded all the, sorry, that's my dog. I uploaded, I went to SAS, I uploaded on the left-hand side each of the weekly assignments, and then I hit run because just uploading it doesn't actually put it in the software, I thought, itself. And I think that's what you said, like, would be really helpful and put us ahead of the game.
Well, yes and no. So
okay.
If you upload it to a folder, right, they're there and they will stay there forever. So as long as you have a folder and you see files like this sitting in your folder, then you're good to go. Then the data files are there and they're ready to use. What you might have seen in one of my videos is once you want to work with that data. So let's say we want to do something with the first set of data and we double click on it, which loads it in this window over here. It's just in the window. It's not actually loaded in SAS until you hit the little running man and run it. And now it's actually loaded into SAS where we could now go in and do things with it, where we can go into our tasks and utilities and we can go to tasks and we can go to statistics, right? And we can, you know, do summary statistics on it and, you know, get mean, medians, modes, and all that crap.
Okay.
So maybe that's what you were thinking. As long as you have uploaded your files and you see them sitting over here in a folder somewhere, you are golden and good to go for next week.
Okay.
You don't need to individually run them. That's only when you want to work with them.
Okay. I wasn't sure, but that helps as well. Thank
Awesome.
you.
Yep.
Can you tell me how long the waiting time is between when you validate your account and when they actually open it up for you?
It's usually within 24 hours.
Oh, okay.
Even quicker. So if it's been more than a day, just keep looking at your spam folder, because oftentimes the emails show up in spam, and especially with you, I'm sure you probably used your .gov or maybe your
Yes.
.mil.
Yes, I did .mil.
Those have a lot of firewalls on them. So yeah, which I'm sure you're well aware of. So so check around. It's probably in your spam folder or even in a quarantine folder somewhere. And if you don't see it after a couple days, then I would suggest maybe using a personal email address or use the franklin.edu email address, because obviously a lot less firewalls than your government.
And it'll still go to your spam probably, because it did mine as well, but at least you can find it.
Yeah,
So,
exactly.
So Susan, I did mine after Monday night's class. And when I woke up the next morning, it was in my mailbox. And I agree with Bridget that I use Franklin's email address and I got a notification saying I have a spam email. So.
Yeah.
Thank you.
Okay. So there you go. You should see it within a day, and it's most likely in spam. All right, everybody. Thanks for showing up. Great lively session. The recording will be up a little bit later tonight. And then I'll see you guys all on Monday.
Thank you.
Good night.
Thank you
Good night,
so
everybody.
much. Bye.
Thank you.